And welcome to today's webinar. This is from our STEM in the Classroom webinar series, and the topic today is actually just STEM in the classroom. We have with us Steve Verkstis from Comstock Park High School and Avery and Kuba. He's one of our STEM consultants here at Kent ISD. Thanks for letting me know, Amy, that you can hear me too. So a couple of things before we get started. You guys can see how the chat works, so feel free to use the chat throughout the webinar today to share any questions or thoughts that you have on the information that's being shared. I know that Avery and Steve are happy to answer any questions that you have. And if they don't answer any questions when you ask them, we will have a Q&A session at the very end of today's webinar. As you can see me in the webcam. You'll soon be able to have a better look of Avery and Steve, who are behind me right now. So you'll see them throughout most of today's webinar, if not all of it. And then off to the right-hand side, you can see the slide deck for today. And they'll be using that to help guide the presentation, but they're going to be flipping between videos and sharing their screen and a couple other things too. So that will change. Also, you'll notice that the layout will change as well. So the presentation will get a little bit bigger when we switch over to that part of today's webinar. So just know that all of these blocks here will continue to appear in the webinar, but they will move around a little bit. The last thing I wanted to mention was even if when the blocks are moved, if they're still a little too small, you'll notice if you look towards the top right of the slide deck that there's these arrows that are 4 arrows that are facing in different directions. If you click on that, it will make that block go full screen so you can see a little bit better. And if you click on that icon again, it will shrink it back down to the normal size. I encourage you to do that later on when we make that bigger, if it's still a little bit too small. So that's all I really have to share. I guess one thing I forgot to mention is that I'm Andrew Steinman. I'm one of the EdTech consultants here today, and I'm also the moderator, which means that I'll be here to help both Avery and Steve as they navigate through the webinar, and I'm also here to help you. So if you run into any technical issues or have questions about the webinar itself, please feel free to just ask me using the chat, or you can send me a private message using the attendee list. If you click on my name, you can then start a private chat with me. All right, so now I'm going to pass things off to Avery and Steve, and they're going to talk to you today about STEM in the classroom. Do it again, mute.
There we go. Now we should be coming through. So thanks for joining us, everyone, for what we hope to be a series of webinars on STEM in the classroom. And like Andrew just said, thank you, Andrew, for the introduction. My name is Avery Nkuba, and I am a STEM consultant here with Kent Intermediate School District. And I'm here with Mr. Steve Verkstis,
teacher over at Comstock Park High School.
And he and I are going to be talking about some of the work that we were able to do earlier this year. So just quick background on myself, and I'll let Steve introduce himself. Been a STEM consultant here with Kent ISD for a couple of years. Before that, I was aircraft electronics instructor here at the Kent Career and Technical Center. I am still an adjunct aviation professor in Muskegon, and actually kind of new to education. I came from FedEx Express, and I just happened to wear one of my old shirts here today to work. I was airport operations for about 10 years out there. The weird letters there for industry certification is aircraft electronics technician, certified flight instructor, airframe and power plant technician, and I'm certified in something called foreign object elimination, which is like not leaving any debris or materials left behind if you're working with aircraft. So I'm very aircraft intensive, and you'll find out why that applies to the work that Steve and I have been doing. So Steve, you just introduce yourself.
Like Avery, I started industry also. I spent 13 years as an R&D chemist, did some tech service, and did some plant engineering. First 5 years of teaching was at Grand Rapids Catholic Central, and I spent the last 18 years at Comstock Park High School. Taught chemistry, honors chemistry, AP chemistry, physical science, honors physical science, and believe it or not, a couple sections of U.S. history in the last couple of years. And so, a little bit different background, coming from more of an industrial background in my younger days, and it's been served me well. And we'll see how we go with the rest of the day.
Yeah, I'm a busy guy there with all the background. So we'll just move forward on the slides. What we'd like to talk to you about today is kind of, I'll talk for a little bit and then I'll hand it over to Steve, and he's going to run with the lesson work that he did in his classroom. I'll just present kind of the Kent ISD definition of STEM, and then Steve will talk about a lesson overview, some of what your students noticed and saw, and then his teacher perspective on how the lesson went, and then we'll wrap it up. Okay, so what we at Kent ISD mean when we say STEM. STEM education is the integration of science and technology, engineering and math to solve those complex real-world problems. So Steve and I's background in business and industry, like he said it best, serves us well when we're working within this area. And then employers of STEM-related jobs nationwide, especially here in Michigan, definitely challenged to stay competitive and recruit talent that can do those things. I'd like to just show you here a minute this video. I'll give you a little preface on this. This is Mr. Hayden Land. He's Vice President of Civil Engineering Programs at Lockheed Martin. And last year I contacted some of my contacts at Lockheed Martin, and we were fortunate enough to have Mr. Land do a Skype call, so forgive some of the video quality on this. It was a Skype call, and he spoke to several educators within Kent County about what he means when he says STEM.
From a STEM perspective, 25 years ago, when I was an early professional, the United States was #1 in STEM, science, technology, engineering, and math. And in a recent survey and analysis by the World Economic Forum, they ranked the United States 52nd in the quality of mathematics and science education in the world, and 5th and declining in overall global competitiveness. Regarding the evolving careers, a typical scientist and engineer that I have in my organization today, they are great problem solvers. They have a problem. They break the problem down, they get rid of the dust, and they find the answer, and then they can act on that answer. Artistic or creative people, they can start with an idea, expand the idea, connect it in different ways, and go in multiple directions. A lot of the jobs that we're starting to see emerge today, such as data scientists, neuromorphic architecture, web archaeologists, nanocomposite engineer, cyberfractologist, biomimicry analysts, which will likely be some of the top jobs of the future, like many of the top jobs today didn't exist 5 years ago. They're going to require people who can do both, convergent thinking and divergent thinking. So the integration of multiple disciplines, be in position to obtain and succeed in dual degrees, be a psychological computer scientist, a medical mathematician, a sociological engineer. Those type of converging disciplines, and having the left brain and the right brain be able to send signals back and forth, I think is something that I'm looking for from education.
So you can see from that video that we're really preparing students for a very different world, really teaching them their future as opposed to our past, which can be difficult unless we're presenting them sometimes with these business-based problems. So now I'd like to let Steve talk for most of the webinar here just about what he did with this classroom activity. Steve?
Click on that? Or?
Yeah. So let me, I'm going to, just in case things go awry here for a moment, we've got to change some of our settings on the webinar, and then you all should be able to see what we're seeing on our screen. So here we go. So if I click this, and I need to stop. Share.
All right.
There we go.
There we go. Well, to preface this, another math teacher and I, back in August, they had a ArcGIS seminar out here in August, and started working a little bit with Mr. Rick Mushing on that. Then Avery was happened to be in the seminar, and there was only, I think, 3 teachers, and he said, "Would you guys be interested in doing some stuff with unmanned aerial vehicles and a GoPro camera?" And it got me to thinking, and we kept in contact, and we put this lesson together. First time putting a multi-stage lesson together, and I believe it was probably was it the first time you guys actually flew the UAV as a
the first time that we did it with some high school students, yeah.
And so it was a very, very unique experience. And I'm going to go over the lesson, then we can come back and talk a little bit about the perceptions, my perceptions after it was done, and some of the students' perceptions also. And what I ended up doing was putting a combination of different lessons together into more of a project and an inquiry-based type activity, which especially in sciences, which we're all going towards now. The first classroom activity part here, we used some vernier equipment, and we some flashlights, meter sticks, and we did intensity of light according to the distance away from the light source. Pretty standard one, where as you get the light source closer to the surface, you get a more intense light, and as you back the light source out, which was a flashlight in this case, the circle becomes greater and greater, therefore the area becomes greater and greater, therefore the light intensity itself becomes less and less. And then we also did that with changing the angle of the light. So for the first part, we related this light intensity, and then we related it to the winter and the winter solstice, and then the summer solstice also. And the first part here was actually another activity where the students had directions, and I combined it into this more of a large-scale, multifaceted activity. And the second part there is the power data. This was kind of interesting. I found out the power, the wattage of a flashlight light bulb, and the students had to start calculating the power or the wattage of light through over the area. This was brand new to a lot of students. I'm teaching this in a 9th grade physical science class. Anytime you start throwing math in there, it gets to be a very, very interesting with their math skills. And so this was new to many, many of the students. The whole idea of ellipses was brought into this, and the math end of things. Everything was done in Google Docs and using tables in there and making our graphs with that.
Actually, this is the document from Google Docs that we're sharing on the screen, right? Is this the one you use?
This is the one. This is the exact lesson I used. And again, this was the first time I did this, and we'll talk a little bit later about things I would probably change on this. We created a line graph. We inserted this into our report. I inserted a couple of videos in there to help the kids do this. Well, from there, where we did the inside the classroom, Avery measured out the area that the UAV was going to fly over.
And just so that we can share that, UAV within the aviation industry as an acronym just stands for Unmanned Aerial Vehicle. We try not to use the term drone because that pulls up a lot of different imagery sometimes for folks, and it's actually the wrong term. So when you hear Steve or I referring to UAV, that's what he's talking about.
So with the area that the UAV was going to fly over, we calculated that area. We had to convert it to meters, and then we found out that the sun illuminates the Earth with approximately 1,400 watts per meter squared. And from there, we said the maximum solar energy reaching the Earth when the sun is directly overhead. And that was probably the easiest part to do, but the kids could understand, related to the flashlight very well. And then we used the sun angle from our UAV data page. And we had the students well, I guess I'll hit that on the next part.
Okay.
And so now we put together an indoor activity, and we're relating it to real world what we did outside. From there, we used a UAV data collection. I think that's part 3.
Staying on 3?
Yeah, staying on 3 there. And from there, we we took the data outside and we recreated the data into a Google Doc, and we also graphed that. And I have a student example here in a few moments to show you also. And we also did a bar graph, and the students had to relate the light intensity changes to the measured sun angles and surfaces. And that is the other thing we put in with this, the light reflectivity off a grass surface, asphalt, and we also used the baseball field.
Yep, the ball field there, you had the, the infield and the outfield, so the sandy part and then the grass areas. We'll show a video from the UAV flight a little bit later so you kind of understand what we're talking about.
Because with the UAV collection, we were hoping to get reflectivity of light off the 3 different surfaces. And we actually did cut out some different plastic, a red, blue, and a green filter, which semi worked for this one.
Mm-hmm.
It's learn as you go type thing here. Kind of figure out what works and what doesn't. So the kids took that data, and then go ahead and get into the next part, if you will. So from there, we used, Avery sent me all the data, all the pictures from the red lens. And we actually, I think we ended up using some satellite data Mr. Mushing collected, if I'm correct.
So what we found was, in this case, we had mounted the GoPro camera, and what we were really looking for was infrared imagery. So part of what his students had done is designed some different lens filters. And like Steve had mentioned before, they had these different lens filters, put some plastic lens filters over top of that GoPro camera. And so they were looking at, different wavelengths. They were filtering that light. But what we weren't unable to get was really kind of that infrared. And actually, we've planned another activity here in a week, another week.
A week from Thursday.
Yeah, so we'll be out. We can talk about that. But we did actually change that GoPro camera to infrared. What you're seeing here, this picture of the UAV flight path, this is actual imagery of the programming software that we use to program the unmanned aerial vehicle. And you can see down here kind of where it was operating over the infield, like you mentioned, of the baseball field, and then out across, a couple of ball fields you guys have up there at Comstock.
With that, Mr. Mushing sent out some pixel values. I believe it was from a NASA satellite of this area that you see on the screen there. And with those pixel values, we could determine what type of vegetation was there. And it really worked pretty well. Where it was green, you could tell it was good for crops. Where it was brown, we actually got some asphalt there on the bottom of it, unhealthy vegetation. And so we used some pixel values. And with that, I incorporated the ArcGIS map. And so kids actually dropped pins on different areas on the flight path and recorded the pixel values and told me what type of vegetation was there. Now, granted, we were pretty small scale, but it worked pretty well, and the kids did a really nice job with this. This was brand new stuff. This was my first time trying to put this material together in a comprehensive inquiry type of lesson plan for the kids with this.
And just to kind of help people understand, if you're not familiar with ArcGIS, GIS stands for Geographic Information Systems. Specialized software, I was going to say it's not unlike Google Maps, but it's not exactly like Google Maps. Very intensive. You can take multiple layers of data and really do an analysis of the area.
I think we can scroll down.
We'll scroll down a little bit here.
So we got the information with the pixel values, and we could get a dead leaf, stress leaf, and a healthy leaf. And what happened on the ArcGIS material, excuse me, that NASA sent us with the pixel values, we actually had, you can see the 3 values below, 150 and above, very healthy, 120 starting to become unhealthy, and less than 100 a man-made surface. And it was amazing. It worked very well. And where the kids would drop their pins, at that pinpoint, they could access the NASA data and find the pixel values here, and then you could tell when they did their ArcGIS maps, they could say, oh, we got healthy vegetation here, we got man-made, and so forth on there. Part 4, again, the whole idea of synthesize data and analyze, and that's pretty difficult for most students, especially I would say anybody to take a whole bunch of different data and synthesize it and put it together and create a comprehensive report or analysis of the area. I'll be upfront. I thought this was going to take maybe a week. I think we might have worked on this at least 2.5 to 3 weeks on putting all this together. We had put their map skills together. We had to put learn how to use ArcGIS. We had to learn some Google Docs. We had to learn how to graph. We had to learn not only a line graph, but how to put bar graphs together and just synthesize all this information into a comprehensive unit plan. And it was, from my end, it was a very enjoyable experience. And for the kids, for the most part, enjoyed it. We got to be outside and maybe probably touching that.
So then we're going to drop back over here. Forgive me just a second. We got to change some of our settings again.
As Avery's getting back to that, would I change some things? Yeah, definitely. First time around, you learn where I wouldn't call them mistakes, but some
There we go.
little hiccups in what's happening.
Okay, so that was.
There's a quick.
Oh, okay.
It was in the chat. I apologize if you addressed it already, but they're asking if this was remote controlled or if it was programmed.
So yeah, for the unmanned aerial vehicle, this was a programmed flight. I do the takeoff manually by hand using a remote control device. But that picture that you were seeing earlier, where you had the yellow lines back and forth, that was pre-programmed by the students into what's called the ground control station, a laptop. And then there's telemetry data coming back and forth from the laptop to the device as it's operating. So it was a fully autonomous mission. Good question. Thanks for asking that.
One thing I'd like to add, the day that we flew this, I think it was 25 degrees out in the morning.
Jeez.
With fog. So it was...
that was a double-edged sword. You talk about, kind of hitting the curveball as it's coming in. So we planned this. It was October?
Yeah, it was probably late October.
So you could think, it should be maybe a little bit chilly here in Michigan, but we were surprised by some advection fog coming in. So we go out there first hour, and it was mostly clear. I've got to be able to see the thing the entire time it's flying back and forth over the field. It only went up to 150 feet or so. But as we programmed it, this fog's coming in, and it took off out there, and I got to talk to the students about the atmospheric chemistry behind how is it that we get this fog? Why is it happening right now at dawn? As you get the heating of the earth and the air starts to move, and we had a really good explanation. And actually, it was cold enough we got some frost on the rotor blades, which was really neat for the students to be able to see. Just putting all of that, like you said, synthesizing. Well, what have I learned in chemistry, and what did I learn about atmosphere, and different grades, and say, oh, well, this is what it means practically when you're using a tool like this for a business type problem.
This was probably one of the most multifaceted activities I've ever attempted, and it was. I would like to do more of this type of things, and we'll talk about what we're going to do a little bit later. Yeah. But it was interesting to note too, is I had 4 different classes from anywhere from 7:30 in the morning to 8:30, all the way up to 1:30 to 2:30 in the afternoon. And then when we looked at the data with the amount of energy that the sun was hitting in the area where the UAV flew, you could see a definite increase as the day progressed and the fog burned off and the sun got higher in the sky. And that we brought into the whole angle of the angle of the sun in the sky. You get more energy as it gets more directly overhead, or as close as it's going to get in October. And so there was, I guess, talk about cross-unit, cross-curricular, many different facets put together.
Yeah, the science, the technology, the engineering, the mathematics. You really kind of hit all of those going through this, I would think. So we'll just move on to our next slide here. Steve, if you could talk a little bit about how this worked for your students.
The students, being outside is always fun. Yeah, and using the UAV, that was completely new to them. They enjoyed that. Now, I'll have to admit, sometimes you take the information and now you've got to start putting the information together. That gets to be, especially with the math, that took a little bit of time. Some of the math skills of some of the students probably not what I was hoping they would be. So we actually covered quite a bit of algebra for the algebra teachers over this 2 weeks, which when they got to that section in their class, it was amazing. The algebra teachers came and said, "Oh, they already had this material," so it was pretty good.
Perfect.
But I think what a lot of them realized afterwards, and it was a lot of hard work. I won't deny that. But afterwards, after they put the reports together, they were pretty proud of these things, because they were a multi-page report with different links put in there. They had different activities they synthesized together, and almost to the student, they were very, very happy with what they put together. We did have them work with a partner if they wished, and that was the other thing, to work in small groups, which is very, very, when you're starting into business, very few people work by themselves. You work in small groups to solve a problem. There's really no right answer or wrong answer. What we saw was, especially what we were looking for, was a change in the amount of energy during the course of the day, and that was completed. And as we showed different reports from different students in different hours, kids could see that, the data does change. It doesn't stay stagnant as you go through a day with the sun's energy hitting the earth.
As measured by both the UAV and the pixel values, which you were analyzing in GIS, but then also their field work
and
that you had
their light
there.
meters, some vernier light meters, which we ended up getting some new ones about a couple weeks ago. So we'll see how that goes.
Congratulations.
Let's see. Any other questions?
Looks like Sam. I'm sorry, Sam. I don't know how to pronounce your last name. What did they use to program the UAV? So the ground control station, free software. We do have that. The UAV is available to any of our Kent County schools. I'll come out and work with, it looks like you're a science at Union High School, so I can definitely work with you on that. Our contact information will be at the end. Get a hold of me. We use something called Mission Planner. So Mission Planner is a software that allows the laptop to communicate with the UAV. You pull up a regular old map and you just decide where it is exactly that you want to fly. You got to be X number of miles away from airports, things like that. And we look at all of that and help the students, again, synthesize, okay, I got this airspace, I got this person's house next door they don't want flying over, I got to stay within the property boundaries, all of these different things that go into, when we go out and actually do this kind of work. Good question. Mission Planner is the answer. So worked a couple with your students there, and then just this article we were going to try and share. And again, I got to make a couple switches here. We can just share this presentation. You guys can download the presentation. But you were in the news with this.
Yeah, which was kind of interesting. I sent it out to my in-laws and so forth, but also many of the students were in there and were interviewed, and that was a big hit. I think probably knew the day before or so that they were actually coming out. And again, when the whole idea of being on the media for a student, and they were media stars there for a few days, and we did link this up, sent some of the students' work to the principal and to our superintendent. I actually set some of the work to Google just to show them as we were using their the whole Google platform. And the kids really enjoyed it. Their comments were well done.
Yeah, insightful.
And so it was a very good overall experience. And I would definitely going to do this again next year and tighten it up a little bit.
Right on. I am going to share this video so you guys can get kind of a read on what it is that the students did by way of video. Now, I'm going to, again, change some settings so you can see what we're seeing on our screen. But what you'll see is this video, the UAV has the camera on it, and we set it down and we have it go fly. This is with the yellow lens filter that your students had put together. So we'll go ahead and play this. Okay, so we unmuted ourselves. Yeah, we were wanting you guys to kind of get a read. So Sam, hopefully you can hear us now. But yeah, this is the autonomous part of the flight, and this is, it's holding those lines GPS down to, tiny, tiny bits of bearings left or right, of course. And this is that yellow filter on the back of rather on the front of the rotor, which is, it was a plus and a minus, because the way we had configured that, it was just kind of, we could tape it on the front of the GoPro, I think.
Yeah.
So we kind of taped it on the front of that and had the unit go and do the flight. Early in the video, you can see kind of the sunlight was reflecting off of the back of that lens filter they designed and was coming down into the camera. So right here, you can see at the bottom left of the photo again. We were joking before it was a UFO. So that you can see the students here off to the left watching the operation. I was out there in the infield somewhere just kind of monitoring what was going on.
So while this was going on, we had different students in different areas doing reflectivity. But
There's a couple.
Yep. The interesting one in the morning with the fog, the UAV flew out of the fog, you could hear it before you could see it. that was pretty dramatic.
Yeah.
Kids are pretty cool.
And actually, on some parts of the infield here, you can see, different reflectivity values coming, even from this very simple yellow filter. You can see healthier and less healthy vegetation. Now, we've got, when we take our next run at this, we've got some different software that's going to image stitch all of these photos together. And what we didn't have that before, so we got this software now. We can take all of these different, may need to adjust the volume of the video here. So we're going to image stitch all these together, and now we're going to have that infrared piece that we were kind of looking at for our science students. And this is just me finishing out the flight. We're going to just do the landing here by hand. I land it by hand. Mostly because I want to make sure it's going to land safely. So yeah, that was kind of that autonomous flight. Any other thing you can see here, again, there's that UFO. It's just the way the light reflected off that lens.
Yeah, most of my students want to know when they can fly it. Well, we'll see when that happens.
I do have some curriculum that goes with that, fly to learn stuff, and we do have a simulator where they can use the same very big radio that we're using to control that and do some practice flights. We can talk about gravity, acceleration, distance, a lot of different stuff.
I think one of the big things was getting the kids out there and collect some real world data. All the data we had, we took, as we did it, and I think that brings home the point. Science is really getting out there and collecting the data and analyzing the data. Not so much a worksheet. Here's some values. Go ahead and decipher the values, but collecting your own, and it gives them some ownership. And I think that might have been the most important piece of this, along with the lessons and the NGSS standards, but the kids had ownership of what they put together here. It was not me giving them a worksheet and fill it in. It was creating a product. And that is, I think, was the most exciting part for myself to see how well they did.
And they did do a great job. One of the neat things, too, I think, is recognizing that this is a burgeoning industry. Part of the reason we see it on the news, and a lot of times you see this stuff on the news and it's, somebody silly went out and crashed it and did the wrong thing and they're going to jail. Well, that's why, Steve's working with me. I'm a pilot and a flight instructor, so we can do this stuff. We can do it safe. We can do it legal. Steve was able to work out permission for us to go and do some work at a park.
Kent County Parks.
Yep. Kent County Park. So that's going to be the next piece, and that's when we're going to take a look at the infrared. We did want to show you some student work example. So again, I'm going to change this so you can see what we're showing on our screen a minute. And we wanted to slide over to the student work example right here.
There's a young man putting first one was a scatter plot for light intensity, and they actually learned how to do the slope and put a line of best fit in there. And you can scroll down a little bit.
Okay.
Oh, yeah. And with the light angle, and we put in what they actually worked with Comstock Park in the winter and the summer solstice and some of the values that they took outside.
Okay, keep moving down here.
Moving down. Here's our power data. And they had to interpret the graph and then go ahead and give us the values that the Earth was illuminated with, the amount of energy in the flight path itself. And this was, for many, many, many of the students, this was brand new material. It was also interesting learning how to create different graphs, a smooth curve graph versus a scatter plot, and also versus a bar graph. And here's our bar graph. And here you can see from the different hours, we collated the data from the different hours, and we did air temperature. We did the grass temperature. We actually inserted a thermometer in there, that in the dirt, and then laid the thermometer on the asphalt. And as you can see, it was pretty cold first hour in the morning at 7:30. And as you can see, through the course of the day, it warmed up, and it was interesting. I asked the kids, do you see any things going on here with the different surfaces? And sure enough, in each instance, the asphalt really collected the most heat, and so it actually absorbed the most energy and reflected the least. And here was the picture of the flight path, and then the student put his link to his UAV Arcus on there. And again, this was another good skill the students use, inserting links into their documents and using the link feature from Google Earth. I guess, a lot of times we come to the classroom with some preconceived notion. These kids can know how to operate all the different tools in Google. And you very quickly learn that many of them do not. And so, again, it's just the skills of putting a report together also.
So we're going to switch back here. So that was that student work example. Steve, if you can talk just a little bit about some of what you noticed during this lesson.
Well, I couldn't have done this. The students couldn't have done this without the help from the guys here at the ISD. They needed some.
Shucks.
Yeah. I couldn't have pulled this off without their help, and hopefully we've got a pretty good relationship now where we can start doing more and more of this.
Hope to. Yes.
Actually, with the use of the veneer products, we're actually end up spending some more of our hard-earned money for our department, buying some more there. The high school standards definitely hit all the engineering technology applications from the NGSS on this, and that's what we did. We already had the light intensity lab. Actually, I picked that up at the Grand Valley Science
Fall science update?
Fall science update.
There you go.
And which had actually come out of Hope College, and that's where this whole thing really started at. And again, the data and the information collected by the student, and the data changed as the day progressed, which I thought was just fantastic because it showed things change as time goes on, which was good. Lesson was current. Yeah, I don't think we could have gotten too much more current than using the UAV flight on collecting the data with this. Different technology. Besides the UAV, the GoPro camera, and the different filters, we brought out the vernier, light reflectivity. We also brought out the temperature probes, and so not counting the use of the Google Docs putting this together. I actually did this was part assessment, part activity, more for the grading part of it. As I mentioned, I didn't look at individual numbers going, no way it could have been that number. What I was looking for on this was trends. Did your numbers make sense? Did the trend, especially for the indoor one, as the ellipse got bigger, did the amount of energy in that area of the ellipse, did it go down? And that's what I was really looking for here. Not the exact value you got each time, but did the trend make sense? And that's what I was looking for the students to find out. All right, does your data make sense? all too often, and I think as teachers we've run through this quite a bit, is that students will put numbers in a calculator, and whatever number they get in the calculator, that's what they put on the answer sheet.
Yeah.
And it's like, but does the number make sense? And that's where I think one thing that this lab really helped. Does your values, what you collected, the answers you come up with, do they make sense? It did. I say it took too long, but I keep looking back on this, and maybe it didn't. Now, granted, I said about 2.5, almost going to 3 weeks on this, but I think it was time well spent. I can foresee myself doing more and more of this type of activity. I think this goes into that whole idea of blended learning, going into activity-based, inquiry-based instruction. And that can't be done in a day or two. And I would definitely like to do more of this type of activity. I think the hard part of this is getting ideas during the course of the year how to pull this off. In fact, we even talked about during the winter running the GoPro or running the UAV in the gym, but I don't think that didn't quite happen.
Did do that with some elementary schools, just talking about gravity and other things. But for your applications, it seems like outside data is what you want for your science class.
Yep. Again, finding the GoPro camera needed an IR lens, which I believe the ISD is taking care of that for the spring.
Yep.
The prep time was extensive putting it the first time together. As I was putting it together, I go, I need to change this. Typical teacher like things, you don't know what's going to happen until you really start to do it one time. Some things change as we went through a lesson. I deleted a couple things, added a couple others. But the nice thing, once you've created it, now you've got something to go back to, and you can always fine tune what you need to do there.
Excellent. So we also just wanted to mention, like I said at the beginning, we are hoping to have a number of these types of webinars. The Career Readiness Department, myself, like was mentioned today, Rick Mushing, we're the STEM consultants. Then we also have an entire other segment of our group in Career Readiness. Trudy No Brown is a Career Readiness consultant, and then Amy Pierce, who I think is in here with us, and then Lindsay Tilley and Krista Harmon are career exploration coordinators. And what they do is they work to connect your classroom to businesses. Now that can mean a couple of things. Maybe they bring, you might ask for some speakers to come in and talk about a topic, or maybe your students want to go out into industry and have some type of experience, and those folks do an excellent job coordinating that type of work. So we are going to have hopefully some more webinars showing some stuff that we've done around the county.
If I can interject what we're going to do next
Thursday. Tell them what you wanted more, so tell them more.
We also do in physical science a hydrology unit, and last few years I've had kids get in their groups on their own time, go measure stream flow, take a cross-sectional area, tell me how much water's flowing through the area, and also tell me the speed. Well, last year the biology teacher who I actually coach track with wanted to do some field study, different plant life, doing the biology stuff that they do with dirt and everything. So what we did last year, we went to a Wallfield Park. It's in near Comstock Park, near Alpine and 8 Mile Road, and we took the whole freshman and sophomore class to this park. So we're talking about 300 students we took out for 2 hours during the in the morning from approximately 8:30 to 10:30. We had to be back by 11 for first lunch, and so we had 150 biology students doing their biology thing. And I had approximately 150 students in the water measuring length of stream, measuring the depth of the water, and using all the calculations back in the classroom to measure stream flow and speed of the water. We also used a computer program where we could actually take a video and put it into this program, and kids could by frame by frame by frame start measuring the speed that a floating object was going by a known fixed object in the background. And so we did that last year, all 300 students out there. Real quick note, we went out there 2 days before we were going to do it, the biology teacher and I, and the stream, it's Mill Creek, and it was only about 18 inches deep. The night before we had to go out there, or the day before, we had about 4 inches of rain. And I went out there that day, and it was about 3 feet to 4 feet high. And I'm going, oh, what am I going to do with 300 kids? So we went out there, and the principal is very nervous. He says, Steve, you're not going to put any kids in the water, because a couple students actually have to get in the water and do the measurements. And I said, if worse comes to worse, I'll do it, and they can all just look. Well, we got out there, and the stream dropped about half its height. So we had approximately 100 kids in the water doing their measurements, too. And it worked very well. Well, so this year, talking to Avery and Rick, we said, boy, it'd really be cool now that we got the IR. Can we fly the IR over, or the UAV over with the IR camera and measure reflectivity of different types of trees and relate it to the absorption of light energy by different leaves? And also, we're going to possibly try to measure something on the stream to get the speed of the stream flow there. And so they got their IR camera. I think we gave them, 700 to 1,000 nanometers. We're gonna shoot it at.
We wanted 750 to 1,000 nanometer wavelength light filtration on the lens.
I think you're going to take burst photos on this one?
Yep. It'll be pre-programmed. It'll take however many we set it to.
So we're going to bring that data back, and then we're going to work with that data also. Again, getting kids out there, real-time data, collecting their own data, taking that data back in the classroom and working with their own data and coming up with a product. And I'm looking forward to it. Look at the weather. It's supposed to be sunny next week, Thursday.
That's a week out. They don't know.
So we'll see what happens with that. So real quick sidelight, it took me about 3 weeks for the Kent County Parks Commission to okay a UAV flight over a county park. They had to bring it all the way up to the lawyer for Kent County to get their permission. So that was an interesting experience also.
That was my fault. I made him ask.
So, again, the collaboration between us and the ISD here, and we're looking forward to it. I'm excited to see how this one goes.
Yeah, I think it'll be really good for kids. And like you keep saying it, and I think you said it best, having kids get out there, solve an actual problem, and use some of this current technology that is going to be absolutely their future. We can wait out in the stream, and we definitely have to vet the data that we're getting. But at some point, it really is going to be about autonomous vehicles and remote sensing, and those are the kinds of skill sets and exposures, I think, Steve, that you're giving your students now, and hopefully that will well prepare them to be leaders, really, in the future.
And what's been, with the science, technology, and the engineering and the math, we've actually engineered our own altimeters when we did the UAV. I guess I forgot to mention that.
Oh, yeah.
Use a protractor and a string and just put a little nut or bolt on it so we could measure that. And it's been fun. I've enjoyed it. I've enjoyed working with these guys. They are a lot of fun. So if you want to contact them, they're good people.
We'll be around. Thanks for that. I've got to pay them $20 afterwards for saying that. But again, hopefully we do have some more webinars like this, just showing, hey, we as teachers don't often get to sit around and talk with each other and say, hey, what are you doing in your classroom? I'm doing this. Can you use some of it, and sharing this? So we hope that the STEM in the Classroom webinar series will help, peel back the curtain and say, hey, this is what I'm doing. Maybe you can use some of it. Maybe you can add to it. Please do. And it's all really it's for the kids. It's for the kids. If there are any more questions, go ahead and just shoot them out there in the chat. We'll wait for just a second and maybe let some of those appear if they will. And if not, I think we'll wrap up. Steve, I do want to ask, I kind of jotted some notes here. As you think about what your students did throughout this, I guess I've got two questions. One, what might have been the most difficult piece for them, or what was their biggest learning takeaway? And then did they have any more wonderings or questions afterwards?
I think probably the most difficult part, and I'm going to assume this is probably true for a lot of schools, was probably the math end of things.
Okay.
The math skills, that was probably the most difficult part for them, just to be able to manipulate the data. The biggest takeaway, I believe, was creating the product. Because they've all kept it in their Google Docs, and I mentioned to quite a few of them, when you guys start those that are going to college, you start looking at a portfolio. This is something you created, and it's multifaceted. It's just not what you wrote on the paper. You've got links in there, and so forth that colleges would like to see on there. The other part, I think, is the whole use of, again, technology, the UAV, the instrumentation, and also just the whole idea of using computer technology and putting your reports together. What you can do now, back when maybe you and I, well, at least when I was a student,
Typewriter.
yeah,
Dot matrix printer.
if we had that, and so just the combining of everything together, I think it may be the greatest learning takeaway that the students had with this.
And again, just reflecting that real world piece of the science, the technology, the engineering, the math. None of the work I've ever done, I'm assuming none of the work you ever done was, hey, sit here and solve these 25 math problems. It was use your math to solve this, reach back into your science education to do that. Use your literacy skills to read and write maybe this technical document. So I think it doesn't get much more authentic than that. What a great experience for your kids.
That's one thing we might add. Hopefully, we're going to do this next fall again. Probably maybe we talk about STEAM with the arts.
Yeah.
Probably put maybe an English composition paper in there. More I can do cross curriculum, the more administration loves this type of stuff. So we'll see how that goes.
So we've got a couple of thank yous from our participants. Thank you for joining us. I think now we're going to turn this. Well, I've got one more video that I wanted to just share with some folks. So we're going to flip over to that a second. This would be an example of what STEM is not, is what we're showing here. So we'll share that.
Dad, can you help me with my math? Mr. Shackelford says if I don't learn it, I won't be able to function in the real world.
Okay, now what you got to do is go down the road past the old Johnson place, and you're going to find two roads, one parallel and one perpendicular. Now keep going until you come to a highway that bisects it at a 45-degree angle. Solve for X.
So hopefully that encourages you, just as you think about the work that you're going forward to make science, technology, engineering, and math real and authentic for your students. And I think that's all Steve and I had. Thanks for joining us for STEM in the Classroom. My name's Avery.
My name's Steve.
And we'll see you next time, we hope. Andrew?
Thanks, guys. All right, so a couple of things before you head out. If you want to provide feedback on today's webinar, you can do so by clicking on the green button that's on this slide. It'll take you straight to the survey. You will also receive a link to the survey tomorrow, along with a link to the recording of today's webinar. So you can click on that, provide some feedback to our presenters and to us here at Kent ISD so we can improve our future webinars. And if you're interested, our next webinar is coming up next week, and it's about going paperless with Google Apps. And we have Kelly Kermode from Forest Hills coming in to talk about how, when she was teaching, how she was using Google Apps to eliminate, or at least greatly reduce the amount of paper that she was using. So hopefully you can join us for that webinar. So I want to say thank you again to everyone that attended today, and again, we hope to see you at our next webinar. Thank you.